pleasure to be here and see that we have so many interested people in the audience. So this is Stockholm summertime, but I will talk on this specific topic as Marlene discussed, and a few other items as well. I will begin to mention that we are trying to focus the research and the endeavors through a foundation that was founded some 5 years ago based on Arne Ljungqvist's legacy. And this foundation, called the Professor Arne Ljungqvist's Anti-Doping Foundation, has the purposes of promoting scientific research on anti-doping matters, and also both in sports and society. We'll come back to that a bit more, because we believe there is a need for focused research and focused outreach in centers across the world. And this foundation supports that, and Arne will dwell a bit more on it. I will mention a few things on what Hans Geier has been doing. First of all, he is a leading scientist in the field of doping analytics, as was stated. And this is just to show the distribution of anabolic agents and other agents, I would say, in the testing over a certain period of time. And you can see that anabolic steroids dominate. Stimulants are second, and then further down the road, all the way to oxygen carrier enhancers, which are basically not detected in this arena. So the focus lies largely to the left with the steroids and stimulants. What's more important that what he would have discussed today is the prevalence of substances in supplements. So supplements that are available in regular stores are allegedly containing certain substances, which may be vitamins or other types of elements, but they are not rarely spiked with other substances, such as anabolic steroids. So what he has shown in studies is that in countries you see the number of analyzed products, the number of cross-contaminated products, and the percentage of cross-contaminated products range between quite a small percentage up to maybe 25%. So overall, there is in the order of 10 to 15% at least of products that you can buy in supplement stores may contain, for example, anabolic steroids. And here he shows in a table in the same publication that, for example, vitamin C sold in Germany and was tested contained an anabolic steroid, metandionone, for example. So you can see that out there in society there is, unfortunately, doping agents available unknowingly, possibly, for the consumer, and Arne might come back to that as well. So gene doping is another type of technology, of course. Gene doping deals with the transfer of genes into tissues, into cells, and it mimics very much the way that gene therapy has been developed over the years. Gene therapy was conceptualized by Ted Friedman in the 70s and has been studied and tried clinically over many decades. There's over 1,000 ongoing clinical trials in various disease areas, and there are a few indications which have been approved for gene therapy. It builds on the principle of entering genes into tissues. I don't know if there's a pointer on this one, but I don't think so. To the right down here, you can see how a vector, a viral vector, is used as the key to open the cell membrane to get the genetic material into the cell, and then it is included in the nucleus and then used for transcription or copying of genes into proteins that are produced. So that's the background, in a sense. For athletes, this is theoretically very interesting if the gene at hand is one that would either enhance muscle mass, let's say, or would enhance red cell mass and blood count. That would improve strength and aerobic capacity, respectively. There are, of course, many other possibilities to influence the perception of pain or the strength of tendons, or you could influence mitochondrial density to have a powerhouse activity with more ATP production, or you could have factors that enhance vascularization, the number of small capillaries in a tissue, which would enhance aerobic capacity as well. So there are many different arenas. And in the regulations within sports, World Anti-Doping Agency has a list of prohibited substances and methods. Method number 3 that is prohibited is called, or headlined, gene doping. It does contain more than gene doping alone, but this is the headline. So the following with the potential to enhance sports performance are prohibited: the transfer of polymers of nucleic acids or nucleic acid analogues, and the use of normal or genetically modified cells. So as you see, number 1 deals with gene doping proper, and number 2 deals with cell therapy mimicking. Now, cell therapy has also been around for a long while, with both bone marrow transplantation for over 40 years, and skin transplantation, and more so cell transplantation for other purposes, be it cartilage in the knee or stem cell transplantation for other purposes. So it's not only experimental, it's clinical. And therefore there's a risk that such methods might be copied and used for performance-enhancing purposes as well. Now, I will mention now that recently in the spring here, World Anti-Doping Agency communicated on its website that the implementation of a method now for gene doping detection is in place for the Rio Games. And this specifically will be used for erythropoietin doping, EPO, which is a very common, I would say, doping agent. And EPO is a hormone in the body that basically leads to the formation of more blood cells in the bone marrow, as such then increasing the blood count, the hemoglobin levels, and thereby performance capacity. And through the work of Dr. Bautina in Australia and her group, this test is now in place, where in a fingerprint way one might detect if a person might have doped him or herself, either the vector that carries the gene or the slightly deviant DNA material that is used for gene therapy with erythropoietin. This is important in itself. This is another way of showing how a gene might be introduced into the nucleus of a cell down to the right with the DNA. And I don't have to go into the details here. In this case, it's an adenovirus vector. So the vectors or the keys that open up the cell are taken from nature in a sense, so that we mimic or copy what nature does in the viral entry into cells. Viruses are experts on entering both prokaryotic and eukaryotic cells and know how to open the cell membrane and transport material, the whole virus and its proteins, into the cell. So what medicine does is basically borrowing a technology from nature to introduce genes for gene therapy purposes. And the same may be used, of course, for gene doping. This is just to illustrate that gene therapy is not any longer something that is only theoretical or a hope and hype. It is coming strongly. And one reflection of that is that the investments into gene therapy from the venture capital community and pharmaceutical companies has increased massively over the few past years. And that's a reflection of now there is a belief that this may take off in a different way from the previous periods of expectations for gene therapy. And this will then, of course, translate into the risk within doping as such. So I mentioned that you can introduce genes into specific tissues or into the blood circulation if you wish, into immune cells. So for example, down to the bottom right here, you can tentatively change the size of the muscle, you can change the number of vessels in the muscle or the mitochondrial number. All of this would increase performance in one way or the other. You could also, to the left at the bottom, increase bone marrow activity or production of blood cells through the release of erythropoietin, this EPO hormone, from any site. Normally in physiology, erythropoietin is produced in the kidney, and the kidneys are reading the oxygen levels of the blood. So if we move to high altitude, 2,000 meters, the kidneys will detect low oxygen and will start producing EPO. And in gene therapy, where this is tried for cancer patients and for patients with renal insufficiency, the genes are not introduced into the kidney because that's pretty tricky and risky. So the genes are transferred into muscle, for example. So you suddenly produce a hormone that's normally produced in the kidney in muscles. And that could be done, of course, as well for gene doping purposes. Apart from the gene doping test I mentioned, down the line, it may be so that one might detect deviant proteins coming out of the production in muscle from anybody that has doped him or herself with EPO, because the way that the protein is glycosylated or covered with a few glucose residues is different in different tissues. So normal EPO comes from the kidney, has its own pattern of glycosylation. EPO that comes from another tissue has a slightly different glycosylation pattern. So that's also another fingerprint element that could be used to raise suspicion anyway. And as you see, there are other possible targets down the line. For example, heart structure to enhance cardiac output and thereby oxygen delivery to the body. One might want to influence what the liver does in the metabolism to improve endurance or other capacities. And for example, the brain to influence pain tolerance. So these are more, let's say, science fiction oriented elements, but they will probably be investigated in science. And to the left, without going into details, you can see some of the factors that are likely to various degrees. And EPO has, as you see to the right there, likelihood of abuse, quite a high likelihood of abuse. And it would have effect as such. And if you go further down, you see VEGF, vascular endothelial growth factor, which is a factor that enhances capillarization or blood vessel density in heart and muscle. That's also quite likely that it could be used. I should state that we don't know whether gene doping has been used or when it will be used, but WADA is now proactive in a very clear way by having funded research for detection over a long period of time, and now we have a test that will be used in the next Olympic Games. So this is the background research for what might be risky, let's say, and there's now tests for at least one of these factors. And down the line, we expect others to be possible to detect as well. And to the right, you see a table of which types of factors are interesting for endurance, strength, or pain tolerance, for example. And you see on the pain tolerance side, we have endorphins and enkephalins and a host of other acronyms that we won't go into for the other performance dimensions. And there are risks, of course. There are great risks with introducing new genetic material that suddenly enhances or increases the production of certain proteins massively. And those include, known from animal studies, not least, and from some of the clinical trials, that the risk of cancer when you introduce more growth factor production than normal is clear. Of course, viral infections, side effects of the viral vectors as such. There may be autoimmune reactions in various ways with very high levels of blood cells. The blood becomes thickened so that there's a risk as a consequence of heart attack, stroke, hypertension and the like. And since you have introduced the material and cannot retract it, if it's transferred as genes, you're stuck with it. That's different from a drug that is washed out. This is stuck in the cells. So one has to think about that too. And of course, direct damage of the muscle with the introduction of these. And of course, you could damage tissues in many ways, but the more serious ones I mentioned above. So the approaches for detection are either indirect or direct. And I won't go much into the indirect ones. You can read out certain pattern changes in blood or in other tissues that may raise the suspicion, but for legal purposes, the direct tests are much more interesting. The indirect ones are merely raising suspicion. And direct ones are when we have leakage into the blood, where we can sample, of either the vectors, the viral vectors, which are foreign to the body, or specific gene fragments. And those are two of the principles that this test relies on. Specific gene fragments, which are different from the natural gene. And of course, you can look also, if that's the case for the specific product, subtle differences between the proteins, the non-natural and the natural. And cell doping might take place either through naked cells, which are just introduced as cells that incorporate themselves into the tissue, or encapsulated cells, where you have cells in a tea bag, let's say, that is basically releasing any desired factor, but you can retract the tea bag once it's done its job. So it's like having a factory in the body, take it out. This is developed for very specific clinical conditions. For example, for Parkinson's disease or Alzheimer's disease, it's tried in the brain. And then the next line of challenge might be gene editing. We don't know yet, but the CRISPR-Cas9 technology has led to many new questions and possibilities in research. Thank you.
Thank you for welcoming me, and thank you for taking me here to Manchester to give some little background to the fight against doping that you see today very much of in media, but also some other part of it, namely the use of doping substances, which is not much of a media matter, but perhaps should be, namely the misuse amongst young people and recreational sports people. A little about the history, though, for you to understand why we are where we are, because without knowing the background, you don't know why you are where you are, and you aren't able to form a strategy for the future. Doping in sport started, anti-doping in sport started 1960, when a Danish cyclist fell dead during the games in Rome. It was the first televised games, live televised internationally, and became a very embarrassing moment for the IOC, obviously. And IOC had not addressed the issue earlier. Sport had not done much to it, and the IOC started to find a way to combat misuse of drugs in Olympic sport by creating a medical committee. It took them quite some years to come up with a strategy. It wasn't there until '67 and implemented first time tentatively and at a small scale at the '68 Olympic Games in Grenoble and Mexico, which included the analysis for doping substances that were known to be misused at the time. And those were basically stimulants, amphetamine drugs, ephedrine, and the like. The first large-scale doping controls took place at the Munich Olympic Games in 1972. I was an Olympian myself 20 years earlier in '52. And '72 I came back as a leader. And from then on I have been in the fight against doping. So it's some decades. And it all started there. I became member of my own sport medical committee in 1972. And when the IF created such a committee, and we drew up a strategy. You should know that the IOC had a limited possibility to conduct an efficient fight, as they had only 1 or 2 games, actually, winter and summer, every 4 years. So the ongoing activities are conducted by the international federations. And I happened to become a member of the IWF Council in '76. And during the time between '72 and '76, I created an anti-doping group inside the IWF and was joined by the 2 scientists that were then working in the IOC, namely Professor Beckett from Chelsea College in London, who was a professor in pharmacy, and Professor Manfred Donnick, who was running the Cologne laboratory. They were both extremely prominent scientists, and we 3 I accidentally happened to be the bridge between science and sports leadership, since I had 1 leg in each team, so to say. So therefore, we started to fight. And we identified that there was not just the misuse of amphetamines and stimulants. And anabolic steroids had been in use for quite some time without the matter having been addressed at all. So we in IWF, we banned this from 1974. And the first time they were analyzed for were at the European Championships in Athletics in '74 in Rome. Olympic-wise, from Olympic point of view, they were firstly analyzed at the Montreal Games in '76 with an improved method that could then also detect some people who were using it. So the first bans came in '76. We also identified the need for highly qualified laboratories. Just, sorry to say, regular, normal chemical laboratories in hospitals and the like were not enough. They didn't have enough safeguards, and instructions to deal with delicate matters like doping analysis, where the laboratory result is the final and must not be false positives. So we introduced laboratory accreditation in 1979, some 7 years before the ISO accreditation started. So we were a little pioneering in that sense, laboratory accreditation. Blood doping became banned in 1984. Up to then, the principle was that substances should not be banned that could not be analyzed for. After the games in Los Angeles, the American cycling team confessed that they had been blood transfusing themselves, and they won the gold. And that made the IOC decide to abandon the principle and make it a list rather on the basis of substances that were known to be used and should not be used, whether they could be analyzed for or not. And that principle has prevailed since then. In 1999, a very important step was taken, namely, there was a chaos of rules. There was a chaos in terms of anti-doping activities in the sporting world, and there had to be some regulatory international body, and we needed the help of the governments, because the rules were different in different countries, they were different in different sports, and we made, IOC made an invitation, issued an invitation to governments around the world to join the fight against doping in sport, and WADA, World Anti-Doping Agency, was created. And they actually came in 2000, I should say 2000 first, we finally got a test for EPO. You can see there's a gap of 16 years between blood doping being banned and EPO being analyzed, possibly analyzed for. EPO came on the market around 1990. So there was a 10 years free way, so to say, for people to use EPO, which was done. And it was done by cyclists in Bay. We know that in principles. In 2005, the governmental part of WADA brought a convention to the United Nations, which landed with UNESCO. And we got the UNESCO convention that clarified that doping is unacceptable in society, particularly in sport. So we have powerful political messages to the world of sport. Doping is not acceptable. Those who argue for letting doping free and let people do as they like, they are outdated today. The issue is closed. It is not acceptable, and that's a powerful message. In 2009, the analytical procedures were to those were added the acceptance of an athlete's biological passport, meaning that athletes will be tested regularly and their counts, whether blood counts or endocrinological data, will be recorded and put into a passport to establish the normal values of each individual in order to be able to see whether at a particular doping control there will be deviations from the expected norm of that individual that could suggest that something irregular has taken place and trigger further investigations. Back to the Olympic Games. At the Games, a large, I wouldn't say majority, but a large number of athletes have been tested through the years. And you have on the left-hand middle column the number of samples that have been taken during the Summer Games. We are in the Summer Games period today. So I limited to Summer Games, which also where also most samples are taken. Winter Games are much smaller. And you can see in London, for instance, he has now amounted to over 5,000 out of the 10,000 participants. 5,000 samples are being collected and analyzed for. And you see, it's just a handful of athletes that have been found. In Moscow 1980, surprisingly no one, 0. The samples were secretly brought out by Doniger to the Cologne lab later, and the 0 figure is not correct. Far from. But such is life. But yet, of course, people hesitate to take drugs before the games with the risk of being found. But steroids in particular are taken during the training periods. And you just stop a few weeks or so before, and you will be negative, although you have benefited from from the effects of the steroids. Now you have read in the newspapers, I believe, that the reanalysis, we are now allowed since some years to keep the samples from the competitions for 10 years and reanalyze them later at our own wish. And now reanalysis has been taking place with respect to samples from, for instance, Beijing and London, and you will have a totally different. Out of the 840 samples that have until today being reanalyzed for Beijing, 60 have come out positive. And we had just a handful at the Games in 2008. And the same for London, we had only a handful. And now we have 38 out of the 400 selected. So why that? I am a little surprised that this seems not to have been paid attention to by journalists. This is a sensational figure. Why? Well, the answer is this. After the London Games, laboratories in cooperation have found that there are long-term metabolites present in the body, in the urine, with people who have taken steroids earlier. The window for detection has increased from a few weeks to a couple of months or even longer. We don't know how much. And this is the reason why this considerable increase in positives have appeared now and this reanalysis is now going on to be as completed as possible before the Rio Games, to identify people who may have been actually doping but escaped earlier during the analytical procedures. There is also an ongoing increasing in sensitivity, of course, of analytical technologies. They are regularly developed, as you know, with GCM, SMS, and high-resolution mass spectrometry, etc. And we also have steadily improved the detection methods for certain key substances, like erythropoietin. So we can probably expect more to happen. But I now turn to the other aspect of the use of doping substances, namely the fact that PEDs, performance-enhancing drugs, have changed, such as amphetamines and anabolic androgenic steroids, have now become more like an image and performance-enhancing drugs issue. And young people are in high school students. There are several investigations around the world from different parts of the world, east and west, north and south, telling the same story of an increasing use of these drugs, not for the purpose of performance enhancing in elite sport primarily, but rather for the satisfaction of body image ideas and a fashion in the fitness culture that is prevailing for good and bad in the world today. And that has become a concern to me and to many of those who have been fighting against doping throughout the years. And the issue was addressed actually already in 2008 by a group of Swedish scientists who emphasized that the use of doping agents, particularly anabolic androgenic steroids, has changed from being a problem restricted to sports to one of public health. And that was published in such a prestigious journal as Lancet. Also, the use of anabolic steroids and other similar substances, substantial problem in Europe, was emphasized by a work that was conducted under the auspices of the Council of Europe. The central organization was the Anti-Doping Denmark. They made an analysis of different countries in Europe with respect to public use of steroids. The countries involved were Sweden, Denmark, Poland, Netherlands, and Cyprus, to give a picture of different characters or different types of countries in Europe. And they found that something like between 3 to 4% of population had some sort of use and relation to anabolic androgenic steroid use. So again, the nutritional supplement issue was emphasized by Carl-Johan Sundberg earlier, so I jumped that. This just tells that this is one source for perhaps unknown use of steroids. where food supplements that are supposed to be just that even contain steroids and doping substances. So to celebrate my 80th birthday some years ago, people were kind enough to donate a large sum of money for me to organize an international symposium, and I chose the subject doping as a public health issue. The support came from the Swedish government, from Swedish sport, from the IOC, and from the Karolinska Institute. And this was the first time that key stakeholders were present to discuss this issue. Not just sport, IOC and WADA, but also WHO and Interpol and UNESCO. And we came to the conclusion that the misuse of doping substances in broader society is a health and security issue, and action must be taken by governments and organizations within a harmonized legal framework. And that's where we are today. Not much has happened, but we are still working on it. And recently, in April this year, a book came out, which is the first sort of textbook intended for students on doping and public health, published by Routledge. Mike McNamee, who will follow me as a speaker, is one of the authors of a chapter in that book, and we hope it to be a bestseller. Not for the purpose of our own money, sorry, it will not be, but for the sake of spreading the message, as you can understand.
It seems that I'm a little bit of an anti-loper, an interloper who's anti-science. Well, I'm not. But what I want to say is, if you think that science can explain anti-doping, I'm sorry, I think you're mistaken. The problem is inherently multidisciplinary, extremely complex, cutting across biology, biochemistry, genetics, to politics, law, philosophy and ethics. And I'll just give you a small flavour of those kinds of ideas today. So here we are at Swansea. We've just built a new campus on the beach. And that was the one day in the last 10 years it was actually sunny. So we sent the camera straight up into the air. When you think about anti-doping, most of you will think of an image something like Lance Armstrong. I don't know if anybody knows who this character is, though. Does anybody know who this is? Well, remember that image. I want to come back to her right at the end. I'll say a little bit then about the basis of anti-doping. And the talk really is going to be science and ethics need to go hand in hand. But we've got to understand what doping is. And it's amazing that a whole corpus of social scientists writing on doping, I think, misunderstand the nature of doping. Because they have the paradigm in their head of somebody taking a steroid or injecting some genetic virus or some similar kind of action. And that's just not good enough, as you'll see shortly. A lot of the scientists working in anti-doping, though, argue two kinds of things, really. What's wrong with doping? What's really wrong with doping? Well, it represents a health risk, a harm to health, and maybe they'll say something about ethics and fair play. And I want to show how the science isn't anywhere near as clear-cut as people think it is in the prosecution of anti-doping policies, and how the ethics is much more objective than people think it is. So I'll probably be a little bit controversial there, because what worries me a little bit about doping is that the issue just becomes medicalized, as if it is just a medical problem. And I think that's a piece of conceptual deflation that takes a complex problem and reduces it just so that one branch of science might better understand it. I'll finish up with some questions for anti-doping policy and science. Well, it does seem odd to start off with a question like, what's the basis of anti-doping policy? Because it should be good science. If you don't understand the scientific nature of the phenomenon, you can't go anywhere. So it's logically necessary, it's absolutely essential, but it's not sufficient. Why? As I've said, because the complex problem is multifaceted. And Arne, in his talk, started to indicate to you the diversity of multidisciplinary subjects that need to be employed to understand and to combat anti-doping. Another proviso that I share with Arne is this one, is that what grabs the headlines in the papers is elite level sport. And it's true that the World Anti-Doping Agency and the national anti-doping organizations focus their efforts and energies on elite sport, which is a tiny, tiny population, minuscule. And even though we have an absence of really reliable, robust prevalence data, everybody thinks the big problem for society is in amateur sports and physical activity and body and image manipulation, using very much the same technologies and products. Now, the world of elite sports, as Arne has said, has come on incredibly in the last 20 years. I was at the 2005 UNESCO convention, and really seasoned political commentators could not believe the swiftness with which nearly all of the nations around the world came to agree on a single topic. And if you thought about any other global issue, think about the international political controversies that follow those. Well, this happened within the space of a couple of days. They got global agreement that anti-doping had to be combated, and that's a fantastic achievement. However, what's quite clear, and came out from a working group for the Council of Europe that we worked on, myself and others, is that there are at least 3 areas that we need to understand much better in terms of recreational sport. The key one is prevalence, but actually prevalence in anti-doping in elite sport is also a problem. If you asked most people a few years ago, what the percentage of positive tests among all those many tens of thousands that are done every year, the answer is something like 1–1.5%. And historically, if you took out cannabinoids from that, it was less than 1%. So that really said something about the sophistication of cheating, and at that time, the lack of sophistication in the doping test. Things have changed very considerably. I noticed the figure from the last 2 Olympic periods is now 8%. So that's a 5-fold increase in efficacy. That's very significant. The substances of choice are very, very interesting. And I want to pursue this a little bit later. I think you hinted at it, Arne. How do you evaluate the health risks of the use of doping products? I mean, I don't know about you, but when you're prescribed simple medication by your doctor, do you read carefully that little sheet which says, here are the potential side effects? How many of you do? Right, there's 3 people in the room put their hand up. And I confess I don't. But those are known risks as a product of carefully controlled randomized clinical trials. Now, when people are doping, they're multiplying the number of agents that they're using, and they have no idea of the risk profile, and nobody does. And part of that uncertainty is what worries us, I think, about doping which goes on in gyms where we know young athletes are simply told by older and bigger and stronger athletes, I use this and that in combination with the other in whatever dosages they may imagine. So the substances, the prevalence, the dosages, the mixtures, all this is research that has to go on very, very urgently. And when we think about the determinants of doping, we really have to separate out motivations by elite athletes to dope from those who simply want to manipulate their images. And this might be, and is to a large degree, young male adolescents who want to be bigger and stronger and ripped and looking like their favorite Hollywood actor or whatever. But it's also policemen, firefighters, security guards, bouncers on the doors. There are lots of other populations who have their own motivations to abuse pharmaceutical products in the way analogous to elite athletes who want to enhance performance. So I said that it's contrary to public and much academic opinion that doping is not simply ingesting prohibited substances or using prohibited methods. There are, in fact, 10 different anti-doping rule violations. So let me just quickly pop them up. So it could be the presence or attempted trafficking of a prohibited substance or method, the administration of it. It could be complicity. This is a very interesting problem. So if you, a doping athlete in the UK, go to your doctor and say, under the grounds of confidentiality, I'm telling you I'm doping. Now, what should I do to minimize the risk to my health? we've got this complex situation in Britain where the General Medical Council says you cannot betray confidentiality. But if you're a general practitioner who's also a committed sports physician, you now could be kicked out of your sport for acting complicitly with doping behaviour. It's one of the anomalies of medical ethics in one context when shifted into sports medicine. And that's a big issue, I think, that people have to work through in terms of the governance structures in medicine and the governance structures in sport. But the 10th is a really interesting anti-doping rule violation. Merely being in the company of somebody who's currently under a doping ban. Now, there are very few spaces in society where we'll say, we will respect the liberty of your movement. But here we want to say, well, we don't really want this person training with that person who's been doping for the last 5 years, who knows the techniques and the substances and the combinations and the timings, and maybe the knowledge of how to beat the doping control officer. So there are very good reasons for having a rule that in lots of areas of society we would find unacceptable. Of course, while I'm giving you all these anti-doping rule violations beyond the ingestion of substances, you're probably thinking of the recent case, but I could put up lots more. There have been several Kenyan athletes caught in the last year for EPO doping, and that's really interesting because lots of people might have had this rather romantic image of African athletes running around in bare feet from the age of 1 or 2, and therefore, for example, in high altitude environments, creating these fantastic capacities. But it's no surprise that Kenyan athletes have been doping too. Why? Because they're human. So doping should not be seen as a problem just in one part of the world, although clearly that some parts are better at anti-doping than other. But we too in Britain have to be a bit careful about slinging mud. So the prohibited list is the heart of anti-doping. This is the list of methods and substances that WADA's prohibited list committee have decided should be thought of as doping substances or methods. And the group is a fantastically highly respected group of scientists and medics. They regularly update that prohibited list. And the point about the regular updates is that you cannot simply claim as an athlete, as Sharapova tried to do, that I was just careless about what products had been shifted onto the prohibited list. Now, there's two reasons for that. One is WADA regularly update and notify everybody of what's on the list. They even tell you what they're thinking of putting on the list. But secondly, and this relates very closely to your question, anti-doping has developed its own jurisprudence. So in anti-doping, we operate with a rule of strict liability. It would be impossible to prosecute anti-doping policy if you had to prove beyond a reasonable doubt that an athlete was doping. And lots of the indirect methods we have to test whether an athlete's been doping don't have to meet that burden at all. So we have one strict liability, it doesn't matter how it got there, it's your duty to present yourself to competition in a clean manner. Whether you deliberately or did not deliberately take the substance, it was in your body, therefore you have a case to answer. But secondly, we don't expect anti-doping jurisprudence to reach the standard of a reasonable doubt. So there are different kinds of jurisprudential standards to prove guilt, or in this case, culpability, because we may be able to prove the athlete did it intentionally, or we may not. But you might have beyond a reasonable doubt, which we don't have. You might have the balance of probabilities, or you might have to the comfortable satisfaction of the panel, and that's the standard operated to. So you might think strict liability is a tough rule, and you might think to the comfortable satisfaction of the panel is a fairly low-level legal criterion to satisfy. But even then we can only catch a small number of the people we know are cheating. Okay, I just want to pick out two things here, really. There are three criteria that might be used for a prohibited substance or method. One is effectively harm to health or potential harm to health. The other is performance enhancing or potentially performance enhancing. And the third is that it violates the spirit of sport. Now, lots of anti-doping scientists and sports medics are really comfortable with the second criterion. It's objective, it's in a language that they understand, and they really don't like the third criterion, the spirit of sport. And it's my position that last one is absolutely essential. Absolutely essential, because nobody objects to people enhancing their performance. That's the whole idea. It's the means by which they enhance performance that we're interested in limiting. Okay. So some people don't like the spirit of sport because it's too vague, but I want to throw a problem to scientists who are now interested in doping. You see, if you have a rule which says the potential harm to health, well, that looks pretty vague to me too. If you say the potential to enhance performance, that looks pretty vague to me too. No less vague than the spirit of sport criterion. Now, what I'm most interested in is how do we prosecute these criteria objectively? I do think WADA, and I'm a strong supporter of WADA, but I'm also a critic too. They do not publish their reasons why they put particular methods or substances. They do not publish them or make them transparent. I think that's a weakness. If you've got good grounds for saying this is so harmful or potentially harmful that we think it should be prohibited, then tell the scientific community and we can debate it. Now, their line of argument has sometimes been, but if we say that, then we effectively instruct people how to dope. Now, I've got this supposition that those who want to dope are probably ahead of most of the anti-doping personnel, so you're not telling them anything new. But I think you'll get greater legitimation and buy-in if you make transparent and justifiable your reasons for having different products and methods on the list. Okay, I think I'll just move on because we've gone on a little bit. How do you determine whether something's unethical? Well, you could say it's about fairness, but you could also say we want paternalistically to tell adults who are otherwise rational and competent what they may and may not put into their body. In most parts of Western societies, we object to that kind of paternalism. In most. But as Arne said, it is just true that if you allow a laissez-faire open market to doping, the idea of sport as a social value will go down the drain because people will, I'm sorry to tell you, just take unbelievable risks. They already do. So part of the thing I don't think we've done very successfully, ethicists, philosophers, medics, is to really say, why should we worry about which harm's in sport? What level of harm should we really worry about? People ignored concussion for years, knowing it was going on. What kinds of products do we need to ban? Which do we need to consider? In the past, we had a harmonized list. Now I'm not sure we need it. Maybe now we need sports to say, these are the harms we want to stop. This is what we'll accept. So in the past, it was crucial that we had harmonization because different sports, some were very relaxed, some were very strong. It's complete inconsistency. Now I'm not sure whether we should move on from that. I'm going to move to the last slide. Why don't you know this person? This is Rosie Ruiz, who crossed the line first in the Boston Marathon. Note, I did not say she was the winner. Halfway round, she ducked out into the crowd, took the metro, and appeared later on in the race and won, inverted commas. A very instrumental and efficient strategy to cross the line first. But sports are gratuitous in their logic. That's to say, we design rules in order to make simple activities really difficult, and we really admire people who overcome those difficulties. So why would you want to undermine the difficulties? You could think how taking the tube is a joke, but doping is doing the same thing. When I gave a talk to the UCI, I had all of the TOR principles there in front of me, and they were laughing their head off when I told them about Rosie Ruiz. And then I said, well, that's what you're doing when you're doping. Silence. They could see this really clear example over here, but when it came to their own preferred method of cheating, all of a sudden they didn't see it as a problem. Now that was the past. I'm glad to say that's not the case now. You could say, Rosie and Louise, you might say, I prefer Lance. At least he was trying to win. At least he put in the effort. But the effort he put in, of course, was assisted in all sorts of ways. So we can do as much science as we like. We can do as much medical research as we like. But it all comes back to the questions of why we value sports before we put in the rules that we really want to. and prohibit the people that we don't. And just to put up the last few questions, I think it's perfectly reasonable that if half of WADA's funds are paid by states parties, those states parties should be asking the question, what are we doing about recreational doping? Not just elite sport. Secondly, I think we have to take seriously doping as a public health phenomenon, not just a problem of elite sport. We do need to think about the ethical considerations much more deeply. And it's just true that different sports have different ethoses. They will accept different risks. We have to batter those out in public. And my last point would be, if the key to all of this is education, and it is, where are the funds for educational research in anti-doping? Almost nil. Thank you very much.